Okay, this is AGECon 410. This is our Friday lab session for the 11th week of the term, and our topic is inequality. So we have been trying to put together economic models to use to analyze policy. Okay, so we see some policy, we try to make it fit into a production type model, a demand type model, a market type model, and those are all appropriate, and they are used to measure sort of economic efficiency, so best outcomes, optimization or optimal outcomes. And those optimization criteria are always about sort of highest or the most, and they also depend on the representativeness of whatever the agent you're using. And so what we have is a condition where either one, you could think of it as the conditions or the sort of underlying assumptions of basic economics being violated, so that we're not getting the most efficient outcome. Or you could just think of it as efficiency may not be the only criteria to consider in policy, and that would be a valid statement because there are trade-offs, there are choices, there are winners and losers, and so equity or inequality becomes an issue. And so if we've been putting together the tools for efficiency measurement in an economics framework, then we should also come up with a tool that let us look at the other sort of piece of the trade-off, and that's the equity side. And that's what we started on Monday in our lecture. We talked about a Lorenz benchmark of everything being shared equally and how it might produce a line that looks like this, where if you measure the cumulative share in the population, so the first 10%, the first 20%, the first 30, 50, 75% of the population down here, then a pure or a benchmark sort of equity situation would be they also have 75% of the income. Okay, and so the percentages here match the percentages here, the proportions, I guess, would be the right way to say it. And this becomes the benchmark. And so anything that deviates, that says some people earn less, right, will cause this to lie below the Lorenz benchmark and then start to curve up as the greater shares come around. And then, of course, if you plot actual outcomes, then 0 and 1 are both common points. Okay, so the Lorenz curve, when you actually plot income outcomes, will bend away from the Lorenz benchmark. And then, of course, we had the Gini Coefficient, which says take the area under the Lorenz benchmark, which is as large as it can get, take the area underneath the Lorenz curve that we might draw in, that looks like this, that bends away from it, and then measure that gap, and that gap is your inequality. So when people talk about gaps, they typically are talking about the gap between the richest and poorest, but we have another gap here that we could measure. Okay, and so to do this, we actually had some data by income category. And the way to do this is to plot from lowest income to highest income, so that you're getting the first 20% of people own 5% of the income. The second 20%, between 20 and 40, ordered by their income size, has 11%. And then this blue curve actually plots the cumulative share of income out here. So 4.7, 15.8, 32.9. And so that's what the Lorenz curve, this is the curve that bends away from the orange benchmark line. We said that we could put two Lorenz curves down here and compare two things to the benchmark and to each other. Okay, so these are both inequality measured relative to the benchmark, but we might be able to say something about if this was like pre and post policy reform, what changes have come about in the income distribution. And then, of course, we said we should measure it with the Gini coefficient. And so the Gini coefficient is taking the area of the triangle underneath the Lorenz benchmark. So the orange thing, if you look, right, between 0 and 100, the way I've drawn it here, and this value for 100 is just it's a triangle. It's actually a right triangle, but you can take the area of any triangle as the base times the height, and then multiply it by a half, right? So it's basically the half, of course, comes because this is a square. This is 100 by 100 square, and so the triangle here bisects, divides the area in half. It's a little different when we do the Lorenz income curves, because they're actually a bunch of trapezoids. So if we make these straight lines, so let's just focus on the blue here, and to get rid of the blue I'll back up one. So this is a trapezoid with one leg or one side here with a height of 4.7, the other one is a height of 0, and then it has a width or a base of 20. Okay, here's another one, another trapezoid, has a height here of 15.8, a height right here of 4.7, and a base of 20. Okay, and so the formula for a trapezoid is to take the base times the first height, or the first leg, plus the second leg divided by 2. And so it's actually the midpoint in between those two. And so if you take this value, 4.7 plus 11.1, and you get 15.8, well, if you take half of that, that's actually where the height at the midpoint. Okay, so that gives us a way of measuring that gives us a way of measuring this out. Okay, so we get all these areas that are drawn through here. We add these up, so here's a trapezoid, here's a trapezoid, here's a trapezoid, here's one, and here's one. We get all these areas, and we just add them up and compare them then to how big is the area under the Lorenz benchmark, and then you take that ratio, and that's the Gini coefficient. Okay, so step 1, get the area under the Lorenz benchmark. If it's 100, if the endpoints are 100, it's going to be 5,000. If the endpoints are 1, right? If you draw it between 0 and 1, then this will be a half. So this is, this value here is not that important. The area under the Lorenz curve, and these L1 and L2 that I'm calling the legs, those are the heights of the trapezoid on the cumulative distribution. And then B is the width of those population intervals. Those could be fixed, like in the example we just had, or they could be some other value, like the example I'll take you through. And then for the Gini coefficient, it's actually take the area under the Lorenz income curve, the one we've drawn, compared to the benchmark, take that ratio, and then the way the Gini coefficient is sort of scored or evaluated is to take that ratio and subtract it from 1. And that's to give inequality measured. This conversion is all about changing it so that inequality grows as the Gini coefficient grows. Okay, and so it's just a complementary measure of the actual ratio here. So 1 minus this will tell you what that gap size is. So as the gap gets bigger, the Gini gets bigger. Okay, so we went through this example and measured it in class, and now I'm going to show you how to do it in a spreadsheet. So I'm going to pause and switch around a little bit, and then we'll go through the steps. Okay, so in your lab spreadsheet, you'll see the sheet called Example 1. And what it'll have, it'll be set up just like this. Everything's filled in for you so that you can go back and get a complete look at this. When your data is organized like this, and it's not uncommon to see an income distribution reported this way, the first 20%, the second 20%, maybe it's in 10% groupings, or 5% groupings, whatever those are called. So deciles, and I think the term for 5% groupings is maybe ventiles. But whatever it is, when it's organized this way, it's the simplest way to do it. The only thing we have to do is order all the groups, by lowest income to highest income. Okay, so that's key to making the Gini or the Lorenz curve bend away appropriately. If you get them out of order, then you are essentially re-ranking income, and you may actually undervalue inequality. Okay, so I've reported, we had this exact table given to us, and so all I've done is sort of rearrange the ordering, and I maybe rounded off some numbers here. But the first group has 5%. The first 20% of the population has 5% of the income. The second 20% has 11%. The third 20% 17%, and so on. And so I've got these ranked from first to fifth. And then I have a null row here, which is just a set of zeros that you'll see become useful for when I want to graph this. Okay, so if we move across here, the important thing for the Lorenz curve and for the eventual Gini calculation is to convert these shares to cumulative shares. Okay, so it's not that they have 5%, it's that it adds 5% to the cumulative income, while adding 20% to the population. The second group, you add 20% to the population, and now you've added 11% to total income. And so to convert these, or to calculate the cumulative shares, so we don't need anything there, it's just to make sure that the cumulative distribution starts at 0, we need a formula. And so here's the formula. So it just says, take the cell right above here, D3, add to it B4, which is the share of income from the first group, and that'll be the new cumulative share of income. If you move down to this one, it's the same formula. Look one above and get the previous cumulative share and add the addition from this row. So 11 is the new group, 11% of income is how much the second group adds, so the 5 plus 11 will give you 16. Same thing with the third row. So move right up one, take the value right above of 16, and then add to it the 17, so it's D5 plus B6. And so this is actually a formula you can make and copy down the row. And then of course over here, if you're adding 20% each time, then it's 20, 40, 60, 180, and you can see it's the same exact formula, so it's just referencing different rows. And then for the Gini area, we don't need an area for the first one, but we need 1, 2, 3, 4, 5 areas between 6 categories. So we start with the first group, and you see what I'm doing here is take the sorry, it's blocking that out. Guess there's no way to stop it. Yeah. Okay, there we go. E4 minus E3, okay, and so that's the base, right? That's the size of the base, which means it should be 20%. That's how wide this piece of the this section of that trapezoid is going to be, the first trapezoid we have. And then the second one says take a half of D4, multiply by a half D4 plus D3. Okay, and this is that average height. So 1/2 times two numbers is always their average. So take the height between 5 and 0, the midpoint, find the height, and that's what you get there. Okay, and so as we move down, you'll see here E5 minus E4, well that's just 20 again, right? So that's just taking the, how wide is the gap? Well, they all are 20. Multiply it by a half, and then multiply by D5 plus D4. So 16 plus 5 is 21, so the midpoint is going to be something like 10 and a half. Okay, and so these are all component areas. These are all Gini areas of the trapezoid that responds, or the trapezoid that goes with the first group, the second group, third group, fourth group, and fifth group. And then finally, when you get to the end, you just sum them up. Sum all 5 of the areas that are important, that matter, together. And then you have the Gini total area. So you found the area under the Lorenz curve, and then to find the coefficient, the Gini coefficient, you need the Gini area under the Lorenz benchmark, which is 5,000 if the boundaries are 100. So you calculate that there. And then the Gini coefficient is just 1 minus, in parentheses, F9, the Gini total area we calculated compared to the benchmark. Okay, so let's just look back at our slides really quick and see what we have. Is this it? Yeah. Okay, so again, we find the area here. Sorry, we find the area under the total orange triangle. Find each of these areas one at a time, add them up, and that's how we're going to calculate the Gini coefficient. And that works okay. And if you can get the data, that's like this, that tells you the share of population sort of broken out by ordered groupings and how much income they have, well, that's great, and that makes for some easy work. That's usually not how we get data. Usually people are very descriptive with their data. You don't have access to the raw data, but you want to approximate something about the inequality. And so what we have to do is work through some problems. So I'm going to leave the completed version here as you do your lab. I forgot to do the Lorenz curve. I'm going to leave this completed version here, but what we're going to work through is how you might take some data that looks like this, first of all, and this is an ERS report that is linked on your lab site, on the lab instructions. So from page 3 there, they tell us, and it's a ERS report on family farming in the United States and how much income is earned by different groups of family farms. And so here you see they're telling me that there are 366,000 farms that they classify as retirement farms. 42% of farms, or 860,000, are what they call off-farm occupation farms. They're small farms, but the primary purpose, their primary income source is something other than farm income. About 500,000 farms are what we call low sales, 100,000 farms that are moderate, and then you just kind of keep moving through it. And so that's some data we would have to deal with, and so I've actually put that together for you in your lab handout, and I've ordered these, and so this row is here for a reason, and so they're just grouped A, B, C, D, E, F, G: retirement, off-farm, low sales, moderate sales, mid-sized farms, large sales, and very large sales. And these are the number of farms that go with each of these. We already know that we're going to leave out non-family farms because they don't have the same data. But we know the first thing that we would need to do here is to get how big are these groups in terms of the total population. And then we know the other thing we're going to need is income. And so let's see how that data is provided to you. If you look at the slides, well, on page 8 of that ERS document, they give you just the average income by group. Okay, so for retirement farms, the average household income is $83,000. For off-farm occupation, it's $127,000. For low sales, it's $60,000. For moderate sales, it's $102,000. And so you end up with a way to recover, right, the total income in any group, because the average here must be equal to the total income for all retirement farms must be equal to the average income times the number of farms. Okay, they have some other data out here, but for now in the example, we're just going to work through this. Okay, and so that gives us our starting point. So the first thing we know we're going to need is how are these farms sort of broken out? What percentage is in each group, because we're going to need all this stuff in share form to eventually come up with the cumulative share of the population. And so the first thing we would do is we'll take the sum to get the total number of farms in the ERS Family Farm Report. And so I have sum of C3 through C9, and we'll use that, and that becomes, looks like it's a little over 2 million. If you like, you can change this to have 1,000 separators. Sometimes I do. And so, you see, and you get an idea. And then, of course, the easiest thing to do then is once you've calculated the total, let's just find out what the share is. We'll just do a straight division, the number of farms in a category, put the division sign in, and then choose the total. And then if you punch F4 on your keyboard, you'll get these dollar signs, and so that makes it an absolute reference, and that gives us a formula that we can, hit paste too quick. That gives you a formula that you can copy and paste down the row, and this is all highlighted, and you can see that the sum, if you look way down here on the right of your spreadsheet, it'll always tell you the sum of the values in the highlight is 1, and that's exactly what we need anytime we're calculating shares. I want to format this for 2 decimal places. That's all I want to see. And now we have share in total farms, which is a value we needed. We have average income here, and what we really need to know is how much income does this group have out of the entire population of 2 million farms. Okay, so I'm going to do it in several steps. So the first thing I'm going to do is total group income, and I'm just going to take here a formula that says equals the average income multiplied by the number of farms in the group. Okay, and so now that becomes a formula that we can copy, and so I'm just copying and pasting that down like this. And again, maybe I don't really want to look at them, so I'm just going to make them all scientific. So these are all just scientific notation. So this is the exponent form of this. Okay, and so because this is a number that we don't really need to focus on, the average is a much easier way to look and decide how much income you have. But we do need to add it all up, okay? Because one of the things what we want is the share of farms in this group and the share of total income, or share of the population's income in this group. So we're going to do another sum right here of these cells, F3 to F9. Okay, I don't know exactly what that number is, but it's big. So there'll be 11 decimals there. So there's a lot of income in farming, but it's still a pretty small piece of the economy. Okay, so we got the total income by group, and so now we're going to do shares. So we'll go share in total income. And it's the same thing as before. So we're going to say equals the total group income divided by the total for all farms. And then we're going to click F4 again, that function 4 key, to get the absolute cell reference so that we can copy this down. Okay, and I do not want this to be in scientific. I want it to be a number with 2 decimal places. Okay, so 13, 46, 13, 05, 10, 9, 5. And now you're starting to get some things, right, that are directly comparable. Things that you might think about in any inequality setting or any distribution setting. 18% of the farms in the retirement class, 13% of the income in the farm population, 42% of the farms, 46% of the total income, 25%, 13%. Okay, and so let me squeeze that row, Now we got we got a little bit of work to do. So we've got the share we wanted, the other share we wanted, and we're ready to make our cumulative shares. But we have one step we have to correct for. These need to be ordered by lowest income to highest income. And so if you jump over here, to the completed sheet, you'll see that I didn't do that. You'll see that I did do that. So actually the low sales, then retirement, then moderate sales have been rearranged from lowest earners to the highest earners. Okay, so let's go back to our lab model. And let's do that. So all we really need to do, and now you can see why I put A, B, C, D, E, F, G out here to the left, is because I wanted to be able to put them back in order that ERS had them. In case I wanted to ever add any data, I want to know how to do that. So this becomes a row that I could use to reorient or to unsort the data. But we're going to need to sort the data from lowest to highest income value. Whoops. From lowest to highest average income, okay? Because the critical part is that we're ordering the population by what we believe to be the lowest income group to the highest income group per person, right? So each of these groups is going to act like a representative of that group. And we know there'll be wealthy retirement farms and poor retirement farms, but we are left with no data to sort that out, so we have to sort it out the best we can by using a representative number like the average. Okay, so let's do that. So if you highlight the entire block up here, I believe, and then go to data and then sort, you should see something that looks like this. Let me put this in the middle here. So as long as this is checked and it says my data has headers, then you can use the header average income for this column, sort it from smallest to largest, click on OK. It won't change any of the actual formulas because we put them in a way that the totals get calculated based on whatever's in the row, and then the shares get calculated based on whatever the total was. And so everything there stays in order, and we get these grouped from average income lowest to average income highest. Okay, and you'll see that it all matches up with what's back over here. Okay, so what's left? We can just look at this and see that now we're ready to do our cumulative population, cumulative income. This is the Gini area row, and we'll be done, and we'll be done with our example. So let's go here. C share. This is going to be the cumulative share in the population, and we need one other thing we can add here, and I guess it's on this one. We're going to, now that we've sorted, let's stick a blank row in, and we'll just start this one with 0 here, and then we'll need for the second one the cumulative population, the cumulative share of income, and those will both start with 0, right? So there's a 0 point to get on that graph that we're going to need to make. Okay, so what are the steps? Well, it's just add the thing that's above, add the share of population that was most recently calculated in the cumulative measure to the group that you're adding in that row. Okay, so it's H3, that's 0, plus D4. And then that becomes a formula that you can copy all the way down. And it should end in 1. Okay, unfortunately this one there's such a small amount of these large farms that it's going to look like it's 1 and then 1 again. We'll fix that in a second. So you end up with 25 and then 43, which is 25 plus 18, and then 49, which is, if you round these up, that gets to 49, and then 91, 97, 1, 1. Okay, so the thing you learn quickly about this income these categories that we were given from ERS is they're not so much income based, they are sales based. But look at this. I mean, the moderate sales group is this dominant group. The off-farm primary is this dominant group that just completely dominates the middle of the distribution, right? It takes us from 49 to 91, so you end up with a small piece of the distribution here after having a couple of sort of even size groups, and so clearly ERS has sort of refined their picture of distribution to be more than just income based. They're looking at sort of lifestyle and some other things, and this was a discussion and debate we had in class before. So we may not have the best data for calculating inequality, but we're going to proceed with it anyway. Because this is a step we're in. If we're not collecting raw data, we are left with however the data is published to us. Okay, and then we need to do the shares of income, so let's do those. These are going to be, so this one used the share in total farms. The share in income is going to use the share in total income. So we add the 0, or the first row, plus the addition of income in share form to the second row. And if you copy those down, you end up here with something that ends in 1. And then since this one didn't has these very low values, I'm going to up my decimal place game here. And so you see the actual population numbers there. As they, the population percentages, as they change it, doesn't repeat the value of 1. Okay, so we get a story here. So you've got something that's less than half of a percentage of the population here. I guess we could make these just a little bigger too. So less than half of a percentage point of the population, right? So 0.01 there would be that. 0.005 would be half a percentage, and they've got 5% of the total income. That's always, a flag for some income being concentrated in a very small group. And they're the very large sales farms. It's one of the reasons they're split out. They control a disproportionate amount of income, and they are what you might call like a bleeding edge sort of farms that have grown to very large size. They have many units, many replicate units operating. They're usually in multiple states. All kinds of interesting things to learn about very large sales farms. But for our purposes, we are just trying to sort through the measurements here. Okay, so we've got our values we need for a Lorenz curve. Let's go ahead and draw the Lorenz curve. I skipped it from the other exercise here, but the point of this is to get a picture of both of these. So we need to add the Lorenz benchmark values. Okay, and so we're measuring proportions not on a 100-point basis here, not from 0 to 100, but from 0 to 1. And so the Lorenz benchmark will just be 0. At a point of 0, the x-axis, I guess we should put the actual values. So we'll go C-share pop, C-share inc. So when this is 0, the share in income is 0. When this is 1, the share in income is 1. Okay. And so it's a good place to start our graph, actually, is using the Lorenz benchmark line. And so I just click somewhere here, and what I do when I want to draw a graph is I go insert, and then there's a specific type of graph we have to use here. It needs to be the XY scatter. Okay, so it's on mine, it's this one, but it'll be the one that looks like it has dots. And then I'm going to use this this line right here, this form of it that has straight lines joined with markers everywhere that there's a data point. Okay, so when I create it, I don't have any data highlighted on my spreadsheet, and so it's not going to pay attention. It's not going to guess and try to draw me a graph based on what it thinks I want. And so then I just go to select data. Then I'm going to click on add, and then I guess I'll just call this the Lorenz Benchmark. And then for the x values, we're going to use this cumulative share of the population, match those up with some y values that are the cumulative share of income, and you get your Lorenz benchmark line. Click OK. And so now we just need to plot our other line from right here, and that's going to be the one that bends away from that. So we just click add, and this will be my Lorenz income measure, Lorenz income curve. For the x values, again, we're going to you need to catch that 0 so that they actually draws it all the way down there. So 0 to 1, C share pop will be the cumulative shares on the x-axis, and then the cumulative shares on the vertical axis or the y-axis will be the income ones. And then for the series name, I guess I already did that. So Lorenz benchmark, Lorenz income, and we have our graph. Okay, so this is our Lorenz picture of what's going on. So we have the blue benchmark, the orange measure that comes from ordering the population, making some assumptions about what average income and who's representative, and drawing all this. So now we just need to know, how do the two areas compare? Okay, and so that's why we'll calculate the Gini coefficients of these. Okay, so I'm going to scoot my graph down here out of the way, or maybe over here, so I can still see it a little bit. Okay, so how do you calculate these again? Well, you can go back and look, but we need, for the Lorenz benchmark, there's really only this point and this point. Okay, and so you could do it any number of ways, but we could do it using our same formula here and just say, give me the width and then half times the height. Okay, and so either one of those will work, but it's just going to be this times this times 0.5. Okay, and that becomes the benchmark area. That becomes the maximum area that you can get. And so now we need to figure out how to get the individual pieces. Okay, so for these, for the first piece here under the orange line, it's going to be, it actually is a triangle, but we'll make the formula look the way it's supposed to. So it's going to go from this dot to this dot, and so this point right here is the cumulative share in the population minus this one. So we might think of the height, right, the first term being this. Where do we measure here? Minus this. Okay, and then for the second one, we need to know the average or the midpoint between these two. So we're going to use this point and this point, the average, or 1/2 times their sum, to get this height. So let's add the formulas. Let's come up here and we'll go the the Gini area, and this will be the Gini area by category. So we don't need it until we get to the second one. Okay, so here we go. We're going to do the width. All right, so open parentheses. So we're getting the base. We're going to go 0.24. And we're going to subtract the value right above it in the same column. Okay, so H4 minus H3. says take the value right here minus this one, and then when we get to the second grouping, the second trapezoid here, it's going to subtract from this value this measure. Okay, and so we'll get the right widths. I guess you could always go over to the share and total farms and get the base if you want. We need to multiply that by 0.5 and then multiply it by that half. That 0.5 is there to get the midpoint of these two values, 0 and 0.13. These are the heights, or the legs of this. So we'll go this value plus this value. Okay, and so this is very much a formula that's going to move down these columns together. It's going to compare this minus this plus this times a half. Okay, so it's getting the midpoint, or that average height from here, and it's getting the width from here. And you get some small area measure. Now we can just copy that down, and you can see the big, large contribution of this big wide gap of people in this one group that we get. Yeah, so by far the area is dominated here by this large piece, right? And so if you were going to be critical of this, well, I probably shouldn't. Well, I guess one of the things I'm going to ask you to do in the assignment is, what kind of criticism would you have, or what kind of preference would you have for data? This grouping is just way too wide, right? And this one compared to these, and even this one compared to the size of these, which are giving you very refined measures, and you can see the amount of bend they get, but this is taking a lot of character away from the distribution. Okay, but it's all over but the crying now, so let's just add up the Gini areas that we have right here as what, 0.36808 sounds about right. And then we need our Gini, so you might call this Gini, and the Gini coefficient is what? It's 1 minus, open parenthesis, the area that we calculated under all of our trapezoids divided by the area under the Lorenz benchmark. Alright, I get 0.26383. Okay. Yeah, so this is our sort of end game that we wanted. We could fix, since it's something I would ask of you, let me just point out a couple things here. If you produce a graph like this, it would be very common to ask you to format the axis to make the maximum 1 for that axis, and to make the maximum 1 for this axis. Okay, so this is a Lorenz curve. It's supposed to be bounded at 0 and 1, and so putting the entire area here would matter. And then you could go up here to design and adding chart elements, and you might add the primary horizontal, right? Because these could be flipped, or because people may not know exactly what's doing, and add a designation or a title for the horizontal axis, and then you could add chart element to the vertical, like this, and then of course you might distinguish between the blue and the orange line, which I guess would be adding a legend, and I like to put them on the bottom. And then of course, you can highlight these and make them bold or whatever, different sizes, not too important, but anyway, that's how you do that. So in the design, and of course this inequality measure, or any kind of data measure that you're using and working through, the presentation or the communication quality of the graphics, something we haven't talked about in this class at all, could be very important. Okay, with that, you're going to see that there's a small lab assignment, a couple of quick questions, and you can work from there. But be sure that you're able to calculate to here. All the answers are already here, but I want you to understand what we're doing, and work through this. And then of course this one's the simpler one, and so you'll see in the lab assignment, right? If you can find data for some problem that looks like this, you'll have a quite a simpler time. If you choose to go the route of the ERS publication and saying something about off-farm income and how it's distributed, or on-farm income, then you can work with some of the numbers here, but you'll be changing the shares. So with that, and the other question, of course, in the lab assignment is going to be this critique that I already kind of brought up about this kind of information, and how it's grouped well, right, for really describing certain pieces of the population, but a lot of it, you can see that they're not very interested in what's going on in off-farm primary or even retirement farms. They are lumped together. They're not giving us classes like they are for these farm category, these sort of professional farms or career farmer categories. That's where all their attention is, right? So they are moderate sales, mid-size, large sales, low sales. They're trying to give you fairly fine cuts on those to understand what career farming is like, and less interested in the other. And so that makes it imperfect data for this kind of measure. Of course, one of the things in the other question that'll be on the little discussion or post-lab assignment is, how does this compare to U.S. inequality? And do you believe it? Do you believe that farm income is more evenly or less evenly distributed? Or sorry, income in the farm population is more or less evenly distributed in the farm population, based on this plus anything else you might calculate in the second part of the lab assignment. All right, I'm going to go ahead and get this thing rendering and post your assignment, but it's all here for you to do, and an important topic that we probably won't get to spend enough time on.